Welcome again to the Industrial Boot Camp Series number 3, and we're entitling this The Mousetrap. I'm Kerry Rose, Industrial Channel Account Manager Southeast, and again today with me is Marty Reagan, Industrial Channel Account Manager South Central, and Nick Weissong, Technical Sales Engineer Southeast, South Central, and West. In our last episode, we examined TIA 568 and TIA 1005 industrial standards and how a standards-based approach to cabling infrastructure will improve our performance, scalability, and repeatability, and operational maintenance within that network. We highlighted and contrasted the variations in TIA 1005 versus TIA 568, including the hardening of equipment, pathways, the six connector channel, and edge connector variations. One of the components of TIA 1005A standard is the classification of industrial areas using what we call M.I.C.E. Next slide. M.I.C.E is an acronym for mechanical, ingress, chemical or climatic, or electromagnetic. M.I.C.E is classified into 3 groups, which are used to distinguish the environment in which the cabling infrastructure is going to be placed or run. I use the term infrastructure to mean any component like a jack or a plug, the cabling, copper or fiber, and the pathway, where the J-Pro hooks or basket or a wire good product, and then any mounting equipment, such as racks or enclosures. And as you can see here, M.I.C.E level 1 is generally considered office grade, level 2 is generally considered light industrial, and 3 is considered heavy industrial. The ratings or the terms at this point seem fairly subjective and open for interpretation, but they're not. Observe that each element has several parameters that are considered among many when choosing the cable, the connector, the pathway systems to use in the manufacturing spaces. And what you see here is like a subset of the extensive environmental conditions that are present in work areas. The standards include many pages, and I'll emphasize there's many pages of extensive detail. Example, concentration levels, fluid pressure levels, crush levels, any type of severity limits for each one of these elements. It's really an eye chart, if you will, for all the parameters within each one of these elements. Because this list of parameters is so extensive, it's often confusing and even misleading and hard to follow. So you can kind of get overwhelmed with trying to select the proper product based on these tables. So suppliers like Panduit of network infrastructure products are now providing guidance to help end users, contractors choose the right components based on TIA 568 and TIA 1005 M.I.C.E guidance numbers. Now, with that being said, Nick's going to take you into how does this apply onto the plant floor. Nick.
Thanks, Kerry. In the past presentation, I spoke about how M.I.C.E was a part of the TIA standards, so I'm not going to dive into that too much today. However, I do want to reiterate that M.I.C.E is a very important part of the standards, and without proper environmental ratings, it doesn't matter how much you spend, you will have performance issues. It's like trying to pull a large boat out of the water with a Corvette. It just doesn't work. And the diagram that I'm showing is color-coded, so you can start to visualize where your different M.I.C.E ratings come into play. The yellow section, or level 1, is representing your data center or office grade level area. In those areas, you typically would not have chemicals laying around that could degrade the cable, and the cable would not be exposed to water or high levels of dust or debris. I would also consider these areas to be low shock or vibration, and everything in the room would be 300 volts or less. As we move from the yellow to the orange, our levels start to change. And we need to start thinking about products that will play well in level 2. The level 2 area is between the edge device on the factory floor and the office area. I like to think of it as that janitor's closet that is now converted into a telecom room. Maybe the AC doesn't work in that area anymore, or the pipes are starting to leak, causing issues with water dripping on open switches. In this area, we might need to start thinking about sealed enclosures or using an industrial grade copper cable. Level 3, and the highest level depicted, is in red on this slide. In this level, we are starting to get down to the edge device and starting to think about products that can withstand extreme temperatures and high pressure wash down, like in the food and bev industry. On this slide, we are using the same type of color code to show the different ratings that can be present in the manufacturing site. As you can see, the control room is showed in yellow, and then you start to move into the work area, the M.I.C.E ratings change, and your color code is now becoming darker. I also want to point out that not all ratings will be the same, meaning I could have a M.I.C.E rating at M1, I2, C1, and an E3. In this case, I would need to make sure that the products I'm selecting match the highest level of each category of the M.I.C.E rating. In my example, if I selected to cover my E3, but I neglected my I1 or I2, then there would be a high chance that I would have performance issues down the road. It is very important when choosing the products that we correspond them with the highest level you are working in to ensure your network performance will be the same on day 500 as it will be on day 1 when it was installed. Marty?
Thank you, Nick. As we've mentioned, industrial environments are harsh and very different from the enterprise area. Exposure to high temperatures and thermal cycling, high pressure spray, movement, vibration are all a major stressor to the cable. The failures associated can be minimized by applying M.I.C.E to your network deployment strategy. The majority of failures are hard to pinpoint, intermittent, and create delay in the times it takes for a signal to pass to a device. These connected devices are at times controlling time-sensitive and potentially dangerous tasks. Network errors can bring a machine down and creating a sometimes a very costly scenario. M.I.C.E affects the selection of products used in the network deployment throughout the factory floor. Proper selection is part of a standards-based architecture and ensures a resilient network infrastructure, one that will